PXY plot, that's basically the data. Okay, let's see what's gonna happen. So, okay, so let's see. Here is the result when you merge the data and interval, okay. High variable line, okay. Here, line marker. Okay, so in the modeling field, okay, we normally use line to represent our calculation result. And then we use symbols to stand for the data. That's why I remove the line between symbols. Okay, that's the first one. And to compare the result, you have to have the identical x-axis and also y-axis. So you have to check if you have the identical scales and units. And for the plot I show you here, indeed, the unit of pressure is different. Oh, sorry.
Makan kan gue bilang makan lagi. Udah bener gue makan.
Okay, so okay, two units shown in the plot, they are in N per Newton per area, and also bars. But you can see the scale are identical. If you multiply by 10 exponent, 10 with exponent 5. Okay, so basically, you can compare the result for the plot. Okay, and you can also change the unit for sure. Okay, but for the pressure with normal per meter square, that unit, and that's illustrated or that's presented by the data point. So you are not able to change these units. But when you generate the model result, you choose the bar as your unit. So you can generate the model result again, but with different units. Okay, with the unit as not Newton per meter square. So you will have the identical units. Okay, and basically from this plot you can see that your model result only validates maybe at a very low mole fraction of CO2. Okay, but with a higher mole fraction, and it underpredicts the result from slightly to significantly. Okay, and then this model, I mean the Penrod model with the default parameters, may not be able to present your data very well. In this situation, you can do two approaches. One is to do the data regression. The other one is to do the data regression to alter the model parameters of Penrod. The other one is to pursue or to use another thermal model, or we say you use another equation of state. Okay? So before we jump into the data regression, let's see the model parameters you are applying again. So you can return to the method. And below the method folder, there is parameters and the binary interactions, and then PRKBV-1. The Kij here, 0.023, is the parameters you are using. And if you don't know what it is or what the equation is, you can click the help, the question mark on the top right. Okay, and then it pops out and Penrod here, and that shows you the equation of Penn-Robinson model. Okay, and here is the Penn-Robinson model with the pressure expression, and it tells you, in addition to the R, T, and there are parameters like A and B. It tells you where what is A and B, their definitions, and also in the parameters A, it equals to the summation of A naught and A1, and in the expression of A naught, in addition to the AI and AJ, that's basically the pure component parameters. And in your system, in this demonstration, that's the A parameters of carbon dioxide and A parameters of methanol. And these two mole fractions. And then in Kij here, the Kij here is the model parameters, I mean the binary interaction parameters. Okay, its expression is Kij1 plus Kij2 multiplied by T plus Kij3 divided by T. Okay, so the Kij here itself, it has its expression is temperature dependency. But if you work, or if your system is at a constant temperatures, you can stay with Kij1 only. Okay, so till now you know the Kij is your model parameters, and let's see what is the relations between the Kij1 and also the PRKBV. Okay, because in the binary interaction parameters folder, you only see the PRKBV-1 and the value is 0.023, right? Okay, so if you check what is this abbreviation, you can see here that's the symbol of Kij1. Okay, and you return to the equations like Kij1, okay, and that equals to Kij if there is no Kij2 and Kij3, and Kij here that can goes to the equation of the A naught. So here is your model parameters. Okay, when you use Penn-Robinson equation of state, and you can see there is no KBij and KCij for the default parameters. That is to say, for the KBij and let's see, where's KB and KC? KBV2. PRK, let's see, we have PRKVV2. No, they don't have. Let's see what is the KB and KCIJ here. Let's see. PRKBV. Oh, KBIJ, PRKBV.
Apa sih dia ini? Ah,
If you search PRKBV, and let's see what they have. Okay, that's PRKBV, KBIJ. Okay, that's the same with PRKB, KBIJ, KFIJ. Default.
apa itu? Hah? Nyari apa ini? Dia nyari apa? Nyari definisinya apa? Dia nggak ngerti.
Okay, I don't know that either. Let's say
Tuh kan dia nggak tahu
we
KBJ itu apa.
did zero. Okay, let's see.
Terus gimana? Cari aja Google KBJ aspek. Itu kenapa?
Okay, I don't know what KBIJ, KCIJ here either, but I guess they are temperature dependency term. Okay. But anyway, the parameters now you are using is KAIJ. Okay. And we will jump into the data regression. So let's see. Can we do the data regression? Let's see. Okay, here, below the analysis, okay, there is estimation and regression. And we are using the data regression here. And then you will come up with this panel, you click new, and DR-1, that's data regression 1. Okay, and so the method here, you stay with Penrod because you are going to regress the model parameters, the binary interaction parameters of Penrod. Okay, again, binary interaction parameters. And you can specify if there is Harris component in your system, but now we don't specify here. Okay, so what's the data set you are going to apply for the regression? That's the BVLE013. And if you choose this data set, they are asking you if you want to assign a weight for this data. The weight is like it's a weighting factors, and it applies when you have a lot of data sources, and some of the data is more reliable. The others are not reliable, and you can put a less weight for the data which is not reliable. Okay? That's one of the case when we use the weighting factors. Okay? So in this case, we only would have one data source. So the weight is 1, that's fine. And for the consistency, they're basically asking you if you would like to perform the thermodynamic consistency check. That basically help you to check the quality of the data. If the data that pass the consistency check, the data may be reliable. But for those data who does not pass the consistency check, they are not reliable. Okay, so you can kick out those data. But here, we are not going to do the consistency check, okay? And then we are, after the setup is done, we are jumping to the parameters. So for the parameters here, you can regress a pure component parameter, binary parameters, or group parameters, or group binary parameters. Okay, but now we are regress the binary parameters. Okay.